Assalamu alaikum. So inshallah today we are going to solve the revision of chapter 4. It has like 3 ideas. The first one is to find the critical and inflection points, and also other questions like finding the intervals of increasing and decreasing, and also the extreme values and the concavity interval. The second question is to find is about the mean value theorem, which is this one. It has like the first question here and the second question here, which is a piecewise function to find the ABM that will satisfy the mean value theorem. The last one is about a theory question. It depends on the critical points. So if we understand this, we can solve this question easier, inshallah. So before we start here solving, I have a good summary about the difference between critical and inflection points and how to find them. So this question may come in the final exam as parts A, B, C, D, okay? So the first thing, when you have a question about critical and inflection points, you have to find what? To find the domain, okay? If you find the domain for critical and inflection points, okay? Find the domain of the original function, okay? And then find the first derivative. After that, you're going to solve it. So f prime of x equal to 0. Here, we just accept only the solutions within what? Within the domain that we find it already in the first step. And then we can draw a graph. But here, when we find the solutions, f prime of x equal to 0, when we solve it, and we have like solutions x1 and x2, they are not officially critical points. They have to satisfy two conditions. The first one, they have to be within the domain. If they satisfy it, okay, we are going to go to the graph. And in the graph, when we draw them, like this one is like first solution, x1. It has to be on the left-hand side, different signs, like positive, negative. We are going to solve a question, and you will know, inshallah, later, okay? So, and then you are going to draw a graph. So later you are going to determine critical points, so solutions who have different sides, like plus, minus, or minus, plus, on both sides, okay? And then you are going to determine extreme values, okay? Two types, absolute maximum or absolute minimum. And the second one, local maximum or local minimum. And the last one is the increasing and decreasing intervals, okay? For the extreme values, you can decide in the graph, this is extreme value, how? If you see like this one, or this one, or a point, like a closed interval, not an arrow, no, a point, okay? These are the shapes of extreme values. This one is called a maximum. This one, max. This one, minimum. So here, and then we will decide, is it absolute or local maximum? But here, this is a shape of maximum. But is it absolute or local? The difference between them, the absolute means it is the highest point in the graph. The local, it is not. It is a max, but not the highest. The minimum is this shape, same as we have local and we have absolute minimum, okay? But this point, when you have in your graph, like this point, so how can you determine, is this a local or absolute? So is this maximum or minimum? So when you have like this graph, okay, like this graph, so this one with a domain from like -2 to 2. So from here, -2 to 2. So it has like, it has like this one here. So a point here and a point here. So is this one a maximum or minimum? You just draw a arrow, okay? An arrow like this one. Is it going upward? Yes, so this max. Okay, maximum. And this one, you're going also to draw an arrow, and then it's going downward. So this is minimum, okay? Okay. But then you will decide, is it local maximum or absolute maximum? Or it is local minimum or absolute minimum, okay? This is for the critical points. For the inflection points, same approach. So you are going to find the first, find the domain, and then find the second derivative, not the first, the second derivative, and then you are going to solve it. Okay, but same as here, you are going to accept, or you have to accept what only the solutions within the domain. Okay, like for example, if the domain is between 2 and infinity, and you have an answer like x1 equal to like 0, it is not within the domain. It is before the domain here. So we will not accept it. Okay. And then we are going to draw a graph to determine the inflection points and to determine the concavity, concave up and concave down. This concave up, this concave down. Okay, same as the increasing and decreasing intervals. So now we are going to solve a question like this one. So how can you solve it? So this one, he will give us in the exam function, and then ask us to find, like the first part, find the first derivative. So it's easy. So first of all, you have to determine the domain. The domain is easy. Since it is like there is no rational, it is not rational function, so it's fine. The domain is from negative infinity to positive infinity. So here, this is the first question, which is to find the critical points and inflection points, okay? So this one is the original function. And as we said here, we have the first step to define or to find the domain. So here, since it is not rational, so there is no problem. The domain is all real numbers. What's mean by the domain? The domain is you can substitute any number in X. Okay, there is no problem. You will not get an error in your calculator, okay? So the domain is from negative infinity to positive infinity, okay? Okay, we don't have any problem with any number. So find the first derivative. It will be 6x squared minus 6x minus 12, 11, 12, okay? Like this one, okay? The second part is to determine the critical points. How? After you find the first derivative, you are going to solve it. Like what? Like you are doing like this. F prime of x equal to 0. And then what? Doing like this. This is the first derivative equal to 0. Solve it in your calculator, mod 5, 2. So mod 5, so mod 5, 3, 6 minus 6 minus 12. So it's going to be what? X1, 2, and x2 minus 1. But these are not officially critical points. Why? Because to be as a critical point, it has to satisfy two conditions. The first one, to be within the domain. So both of them, they are within the domain. Okay, so they satisfy the first condition. The second condition we can note where after we draw the graph. So here we are going to draw the graph. So this is the question. We are going to draw the graph. How can we draw the graph? First of all, put the domain. The domain is where? From minus infinity to positive infinity. Then put the solutions that they are within the domain. So we have first -1 and then +2. And then you have to find what? The y values of these x values, okay? So substitute it in the original function. So substitute here, -1 here in this original function to find what? The y. So substitute it here, okay? So it's going to be 2 minus 1 cube minus 3 minus 1 square minus 12 multiply minus 1 plus 5. So it's going to be 12. Okay, so put here this point. The x is minus 1, the y is 12. How can you find the 12? Just substitute it in the original function. And the 2 same as minus 1. Just substitute it in the original function. To find what? To find the y. So to find this point, where is it? So it's going to be minus 15, which is down here. Okay? Okay. So it's minus 15. So here is the point 2 with minus 15. Later on, you have to determine the signs. So here the signs, like here positive, negative, positive. How? After what? You choose a test point. Like here, I will put a sign here, positive or negative. How? You have to choose a test point. So minus infinity to minus 1. Take a test point like what? Like minus 3, because it's within this interval. So minus 3, and then you are going to what? Substitute it where? In the first derivative, this one. Okay, that you find it in part A, this one. So take a test point between minus infinity to minus 1, like minus 3. So 6 minus 3 square minus 6 multiply minus 3 minus 12. So it's going to be positive number, 6c. So put here positive number, positive sign. And then take also a test point between two these points, like between minus 1 and 2. Any test point will be what? 0. So just 0 or 1. They are between these interval. So like 0. Substitute where? In the first derivative. So it is negative. Okay, then choose also any number between this. So like what? Like 5, 8, any number, okay? Between 2 and infinity. So 5. It's also what? A positive number, 108. Okay? So now we can say, now we can determine where are the critical points. Okay? So minus 1, is it a critical point? Yes. Why? Because it is satisfy the first condition between the domain, so yes, and it has different signs, like on the left positive, on the right negative. So yes, it is officially a critical point. Okay. 2, also it has different signs, minus and positive, so it is officially critical point. But let's assume that 2, it has like here, we delete this, and it has only what? Minus. So 2, it is not a critical point. Why? Because it has the same sign, minus, minus. Okay. So now we can say, because it has like 2 different signs, same as minus 1, so it is a critical point. Okay, good. After that, just draw and connect the points. Like this one is what? Is increasing. Yes, positive means increasing. So we are going to go from here just toward the point. And then what? Minus, so go down, decreasing. And then positive, go up. I will put an arrow like here and here. Why? Because we have positive infinity. But if we have the domain, like it is like from minus infinity to, sorry, it is like this, minus infinity to like a number like 4, this one. So here we have to stop. We have to not put an arrow. Okay. So like if it's like from minus infinity to 4, so this one has not, and should be what? Should be an arrow like this one. Okay. Okay. I have a good information. Okay, which is if your graph has an arrow like this going upward, then officially you will never have an absolute maximum. And if you have an arrow going downward, so you will never have absolute minimum. Why? Because if you have an arrow like this going upward, you will not have absolute maximum because it will be always going up, 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 up. Okay, so this point cannot be absolute maximum. Okay, so because this is higher than this, was still going to infinity. Same as going downward. If we have an arrow like this one going downward, so we will never have absolute minimum. Okay, let's go back to the original question. Here is positive infinity, so it's going upward. Okay, so because of these two arrows, you will never have absolute maximum or absolute minimum. So as I told you in the beginning, this is a shape of extreme value, like this one. And this is a shape of extreme value. Okay, so this one is what is a maximum. So this is what, local or absolute? Of course, local. Why? Because we cannot have absolute since we have an arrow like going upward. Okay, so this is what local maximum. So we are going to determine where are the extreme values. We have just local max at what? At this point, at -1 and 12. And we have what? Local minimum. Why it is not absolute minimum? Because we have this arrow. Okay, so it will never be the lowest point. But this one will still going downward. Okay. Okay, so local minimum, it will be at what? At 2 and -15. And that's it for the part D. Part C, increasing and decreasing, very easy question, same as the concavity, concave up and concave down, just looking for the signs. Increasing, look for the what? For the positive signs. So this one and this one. So these are the increasing. So the positive signs for the increasing, the negative signs for the decreasing. Okay. So, and always the increasing and decreasing intervals, it's always open intervals. So it is from where to where? The increasing in will be from -infinity to -1. And you have another positive sign from where? From 2 to infinity, from 2 to infinity. Decreasing signs is from -1 to 1. It is here. So from -1 to 2, sorry. So it's done the part C and part D. The next question is about the inflection points. To find the inflection point, you have to find the second derivative. So we have the first one, which is this one. Just differentiate it more. So you will have the second derivative. So the differentiate of this one is going to be what? 12x minus 6, and that's it. So this is the second derivative. This is an easy question, but you are going to solve, inshallah, much harder one, but it's long. So I solved it before. Okay, okay. Determine the inflection points. Just solve this. So to find the inflection point, you have to solve the second derivative. To find the critical points, you have to solve the first derivative. So find inflection points, just find this. Oh, sorry, before this, you know that the domain is this one. So we have to, our solutions has to be within this to be a critical or inflection point. So solve this. Wait, solve this one. It's going to be what? F double prime of x equal to 0. 12x minus 6 equal to 0. So x equal to what? Equal to 2. Yes, sorry, half. So it's going to be what? Half. Okay, but is this an inflection point? Not yet, but the first condition satisfied. It is within the domain. Yes. The second condition, we can know it where? From the graph. Draw the graph. Easy, like this one. Put the domain. The domain is from where to where? From -infinity to +infinity. Okay? Okay. And just now put the solution of the second derivative. That's maybe an inflection point, maybe, okay? So put it here, okay, and then just find the y of this point. Just find the point. So you have to substitute it in the original function to find the y of this point. So substitute here in this original. So 2 multiply 1/2 cube minus, okay, and so on. So it's going to be what? Minus 3/2, okay? So the point is down, since it is negative, so it is 1/2 minus 3/2, okay? Okay, now just put the signs. How can you put the signs? Here, since it is a graph for friction points, so to determine the signs, take any test point, like I want to put a sign here, take any test point between minus infinity and 1/2. Any point, like what? Like -3, -5, 0. Okay, no, 0, 0, no, 0 is here. Okay, so we cannot put 0 here as a test point. Like anyone here, like no, sorry, 0. We can determine 0 because 0 is here. Sorry, 0 and half and 1 and okay. So 0 is within this interval. Okay. Okay, so 0 or -1. Okay, -1. Okay, -1. Take it and substitute it where? In the second derivative. You know, the first, second derivative. This is for the inflection, not for the critical. So it's for the inflection. So -1, -2. Substitute here. Okay, -1 as a test point and see. If your number is negative, put it here as a negative. Okay? Okay. Now determine any test point here, like from half to infinity. Like what? Like 3. Okay, substitute 3 here in the inflection, in the second derivative. Let's give me what? 30, which is a positive number, and that's it. So we draw the signs, and now we can خلاص finish. Just draw, connect the lines. So connect it easy. How can we connect it? Just like this. So it is decreasing, yes. So let's go like this. Okay, increasing. So let's go like this. Okay. So it's going from here to this point that we decided earlier, and they're like this, and then finish. Why we put arrow? Because we have infinity. We have minus infinity. Okay, so that's it. Here we are not going to determine the extreme values, just the concavity. Where is it? Concave down, concave up. Easy. So same as increasing and decreasing. Increasing is the positive signs. Here the concave up, the positive signs. Okay. There the decreasing, it is the negative signs. Here the concave down, it is the negative signs. Okay. So same approach. Okay. Okay. So the concave up, and always the increasing and decreasing. Also the concavity, concave up and concave down, always open intervals, not closed intervals. So concave up between what? Half. Where is the sign, positive sign? Here. Half to infinity. Concave down from minus infinity to half. And that's it. So this is the first question. Okay. I will just take a picture for this one and send it over there. Okay. If you have any questions, ask. Okay, so we can go now for the second question. The second question is more harder than the first one. Why? Because this one, it has a rational function up and down. So the domain will be like a little bit harder. So since it's a rational function, numerator over denominator, so we have to what? To determine the domain, we have to solve the denominator, okay? Just like this. X cube equal to 0. So x equal to what? 0. So the domain is all real numbers except this solution, 0. Okay? Which means that if we substitute any number in your calculator, you will get a number. But if you substitute 0 here, you'll get an error. Why? Because it is not within the domain. Okay? Like it is an illegal number. Okay? Okay, so this is a domain. The first step is to determine the domain. The second step is to find the first derivative. Since it is rational, so we have to use what? The quotient rule. Okay? That's easy. We studied this in chapter 3. So just differentiate it. U prime multiply V minus U V prime over V square. Okay? So we are going to have what? This is the first derivative. Okay? Okay. So now there's a little bit like difference in between the second and first question. Here, to determine the critical points, you have to solve the numerator and denominator. Okay? So solve the numerator. Take this one and equal to 0. And solve the denominator. Take this one and equal it to 0. And then solve in your calculator. So like here, x minus x squared. So I take this, okay, and then minus x squared plus 9 equal to 0. In your calculator, mode 5-3, or solve it manually, you will get two solutions: x equal to 1 and x equal to x equal to 3 and x2 equal to minus 3. Okay, okay, but ask yourself, are these two solutions are officially critical points? No, not yet. They are within the domain, yes, so they satisfy the first condition. Okay, the second condition after we draw. Okay, but this one, it is not within the domain. The domain said I can accept all real numbers except what? 0. So this one is not a critical point. Okay, why? Because it is not within the domain. But these we can check here in this graph if they are critical points or no. Okay, how can we draw? First, okay, to draw this, first you have to determine what? The interval, like this one. Okay, if I remove everything, okay, remove this, remove this, remove this, determine all the first thing, the domain, which is what? From minus infinity to 0, and then from 0 to infinity, to positive infinity. Why I put like this? Because it has no y value. So just like this. Okay. If you can see the graph of the tan or cot, you will see that is like accept some numbers and reject some numbers. Okay. So going back, okay, that's it. So how can we solve it? Just now substitute this one minus 3 in what? In the original function y to find the y value of this number. Okay, just substitute it. We did substitute here, and we get what? Minus 2 over 9. And when we substitute 3, we get 2 over 9. Okay, okay. And then we determine what? The signs. So here, take any test number and substitute where? In the first derivative. So you will get what? A minus. And then you will get plus and plus and minus, as we did earlier. Okay, okay. Now when you draw, so here it's what? It's decreasing, so go down, and then it's increasing, go up. Okay, but don't touch the line here. Don't touch this one. Why? Because it has no y value. Okay, and here go up because it's positive, go up, and then what? Touch the point and then go down. And then you can finish the question. Okay, so where are the increasing and decreasing points? Easy. The increasing are the plus signs, and the decreasing the negative signs. So it is going from where? The increasing from minus 3 to 0, and from 0 to 3. Why I didn't put from minus 3 to 3 directly, like from here to here? Why you just put from minus 3 to 0 and then from 0 to 3? Because it has, because 0, it is like not within the domain. Okay, so you have to make like from 0 to 3, and then from 0 to 3, from -3 to 0, and then from 0 to 3, sorry. But if I put like this one, it means that I put the 0 within this interval, which is not. Okay, okay. And then the decreasing for the negative signs. Okay, this one and this one, easy. For the extreme values, same as we did. This one is, was like this, so it is minimum. Is it local or absolute? Absolute. So since we have this arrow, so we will never have absolute minimum. So it is a local minimum. Okay. Is this one? Because you know this one is maximum, but is it local or absolute? It is of course local. Why? Because we have this arrow. So we will never have absolute maximum. Okay, and that's it. Okay. Then find the second derivative. We have already find the first derivative. So the second is this one, same as we did quotient rule. Okay. Then to determine the inflection points, you are going to solve the numerator and solve the denominator. Okay. Solve the numerator just equal to 0. So you will have what? Two numbers, but still they are not officially inflection points, but they are within the domain. Yes, correct. But the second condition, we can know it from here. This number is not within the domain because the domain say that all real numbers except 0, and this is 0, so we reject it. Rejected marfu. Okay. Okay. Then we can draw as we did. Okay, so same thing, but the signs to determine them in inflection points, you have to take a test point and substitute it where? In the second derivative. But in the graph of critical point, the signs you have to take a test numbers and substitute it in the first derivative. Okay. Okay, so you find this one easy. And we can say that this is a critical point. Why? Since it has different signs. Okay, both sides. And this is also a inflection point. Why? Because it has different signs, left and right. Okay. Okay. Where are the concave down and concave up? Sorry, C should be what? Should be concave up. Okay. So the concave up, it is the positive sign. So this one from -3 √2 to 0, and from what? From 3 to positive infinity. The concave down, only the negative signs. Okay. So concave up is like increasing the positive sign. Concave down is like decreasing. Okay, the negative sign. Okay. So this is the first question for the critical and inflection points. Okay. So if you have any questions, just ask. Okay, going to the second part, which is the mean value theorem. The mean value theorem, it has a formula. Okay, but be careful. There is something like here. Something here. Which is this one. That say that let f be continuous on what? On this closed interval and differentiable, but be careful, that says what? On open interval. Then there exists a point C in which interval this or this? No, it is on the open interval. So be careful, it is not the closed, the open. So we have a equation f prime of C, the derivative, equal we have, I think we have seen this in chapter 2. Yes, this is the average slope. Okay, f of b minus f of a over b minus a. How can we solve? We can solve now this question. This question, how can you solve it? You can solve it like this one. So how? So this one, just put the equation. So I have already the solution, so because there is no time, but it's here. Where is it? This one. Okay, so just put the equation. F prime of C equal the f of b minus of a over b minus a. So find the derivative of this. So it's going to be what? This. But the formula said f prime of C, not f prime of x. So you have to change the variables from x to what? To C. Okay, okay. And then find the right side, which is f of b minus f of a over b minus a. Where are the b and a? This is the a, which is -2, and this is the b, 4, okay? Okay, substitute f of b means that take b and put it here in the function. And the minus f of a means that take a and substitute it here in the function. So you are going to have 0 minus 0 over b minus a, 4 minus -2, and then it's going to be 0. Okay, so this is the final equation. This is f prime of c, and this is the result of f of b minus f of a. So just shift solve, we are going to have two solutions. We may reject one, or we may reject both of them, or nothing, okay? They have to be within the domain, or within the interval. But which interval? This one? No. It has to be the open interval, this one. -2 to 4, which means that if our solution has like C2, if it's like this, C2 equal to 4, then we have to reject it. Why? Because it is not within the domain. It is not within the domain. Why? Because it's open interval at 4. But if it's like C2 equal to like 0, it is within, so accept it, okay? Okay, so be careful, we don't take the closed, we take the open interval. So this is within, yes, correct. This is the within the domain, yes, it is -1.1, it is within the domain, this one. So accept it, and that's it. The second one, same as we did, but it has to be what? It has to be and then okay, we have to solve it. Okay, so what? F prime of C equal f of b, same as the first question, f of b minus f of a over b minus a. So differentiate this. So it's going to be let's like I will make it up. So x plus 54x minus 1. So it's going to be what? 1 plus, because the differentiated of x is going to be what? 1. And then this one is going to be minus 54x minus 2. Multiply and subtract by 1. Equal f of b minus of a. This is a, and this is b. Okay, so f of b, take b, which is this one, and substitute it here. So you are going to have, like, if we just hurry up, here it's going to be 0. Okay, f of b minus of a is 0. Okay, divide by b minus a. This is 9 minus 6. We don't care because 0 divided by anything is going to be 0. Okay, except the denominator is 0. So it's going to be what? 0. Now we can solve it. How can we solve it? It's hard to solve it in your calculator. So because it's not like x squared, it's x power -2. So we have to make it like some magic. So go here. Oh, sorry. This one should be go over there. I like positive numbers, so go here. So it's going to be like this. Okay, 1 equal 50. Oh, sorry, I didn't change the x to c, so I have to change it because he said f prime of c, not f prime of x. Okay, I have to follow the rules. Okay, so c minus 2, and then just switch. So same thing. And then just because it's minus, so it's going to be downward. Okay, like this one. This minus going to be downward. Okay, equal to 1. Cross product. So it's going to be what? 54 equal c square. Go here. C square minus 54 equal to 0. Multiply 3 is going to be what? 1 minus 54, 0. Or you can just square the two sides as you wish. Okay. So the solutions is what? These are the solutions. C1 equal, okay, C1 equal, sorry, 1, 0 minus, okay, it's going to be what? C1 equal 3 root 6, which is the 7.330, okay, this one. And then C2 is what? It's minus 3 root 6, minus 3 root 6, which is this one, minus 7.34. We will accept this one since it is within the domain 6 to 9. But we are going to reject this one because it's not within the domain, okay? That's it. The last question, which is this one, how can we solve it? This is an easy question, but you have to know what is mean value theorem. So mean value theorem, it has two things. The function has to be continuous and what? Differentiable. Okay, continuous and differentiable. Continuous if what? If limit exists, like this one, lim x approaches to this number from left equal from right. And the function should be equal to the limit. Okay, or the function should be equal to the limit from the right, or the function should be equal to the limit from the left. So you have to do all of these. So I have to solve it in two parts. Solving using continuous formulas, okay, and the differentiable, which is this one. Differentiable when the derivative from left equal the derivative from right. We are going to know how now, okay? So just differentiate, so just solve for the continuous. Continuous, I want to use one of these yellow formulas. Which one I can? But before this, we know from here that we have what? How many? What are the interval? What is the interval? It's from 0 to 2. So it is from 0 to 2. Okay. Okay. That's it. And also, do we have like? And also, yes, we have to know that less than means from the left, greater than from the right. Like this one is going to be lim x approaches to 1 from the left. Okay, and this is also a piecewise function. So this is a function. This is also a function. This is also a function. So multiple functions in one function. It's called piecewise. Okay. Okay. So I want to use this one from left and right. Or wait, I can use this also. This one, because it is a mean value theorem. So he want to find A and B that satisfy the mean value theorem. So I know this is a mean value theorem. Okay, so I know this is a continuous and this is differentiable. Okay, so let's use this function. F of c equal lim x approaches to c from the right, which is the only one that has f of the function is 0. Yes, equal means f of, okay? So f of 0 equal lim x approaches to 0 from right. Why? Because it's greater than of this function. Okay? Just now substitute f of 0 is what? Is 3. Just put 3. Lim x approaches to 0 from right, just substitute 0 here. Okay? Oh, sorry, here. So it's going to be, this one will be deleted, this one will be 0. And then it's going to be what? A. So A is equal to what? Is equal to 3. So this is the first one. Can we use continuous functions like this one? Yes, we can maybe use this one. This one. Because we have a number that has left-sided, left and right. Which one? 1. 1 is the only number that has left and right. This is left and this is right. So lim x approaches to 1 from left of which function? Of this function. Equal lim x approaches to 1 from right which is this one. Okay, mx plus b. Just substitute directly. We are going to have, but wait, did we find a? Yes, so here just substitute what a as 3. Okay, okay, substitute directly now 1, so it's going to be what? Minus 1 square plus 3, 1 plus 3, so it's going to be what? 5, equal to what? This one, so it is m plus b. Keep it in your head or in your mind that this is, we are going to use it later, okay? M plus b. Okay, so can we use the continuous functions? خلاص, we cannot use this because we don't have, like, I want to use this one, we use it. I want to use this one, I use it. This one, I cannot use it. Why? Because we don't have a number that has a function and from right. I don't have, okay? Okay. So خلاص, finish the continuous part, finish. I want now to use the differentiable. How? Just differentiate all this. But be careful, when you differentiate, okay, the equal will be removed. That's it. So I want to just change this piecewise to be from f of x to f prime of x. So f prime of x equal, I will differentiate the whole thing. So 3, it will be 0. Minus x squared will be minus 3x plus 3, and 8 is a constant, it will be 0. And then mx plus b, it will be m. Okay, and the b, because it's constant, it will be removed. The intervals, as I told you, the equals will be removed. It will be non-equal, not equal, okay? And then the same. And then here, the equal will be removed. So less than 2, greater than 1. Okay, so we differentiate the whole piecewise. I want to use this formula. I can use it. How? It says that the derivative of from left equal the derivative from right. So which number it has both sides, like left and right? The only one is what? Is number 1. It has left and has right. Less than means left, greater than means right. Okay? So I can just substitute it here. So minus 3x plus 3 equal from right, m. Okay? So substitute 1 here. It's going to be what? Minus 3 over 1 plus 3 equal to m. So m is going to be what? It's going to be 0. Okay? So that's it. So m, it's what? It's 0. Just, I want to make sure that's 0, not any number. So minus, sorry, it is minus 2. This one is minus 2. Yes, it was minus 2. Yes, minus x squared. So it's going to be minus 2x. Sorry. So minus 2x minus 2. So it's going to be what? Here is going to be 1. Okay? Okay, 1. And that's it. I think I told you that we are going back to this one. So just substitute m here and that's it. So 5 equal m plus b. 5 equal 1 plus b. b is equal to what? 4. And that's it. Okay? So here are the solutions. M equal to 1, B equal to 4, and A equal to what? 2, 3. And that's it. Okay? So use like these two, continuous and differentiable. Why? Because he said that is already mean value theorem, but he wants what? He wants the values of A, B, M that satisfy the mean value theorem. Okay, let's go for the last two questions. Here's a theory question. An open top box, okay? A box with no top is to be built by taking 6-inch the width and 8 and 10-inch. How we know that this is the width and this is the tall? That's it. And the first number is always the width, the second number is always the length. Okay? Sheet of cardboard, cutting x in squares. So we have a box that we cut these squares. Okay, so it's become like this. Okay, that's it. And then out of each corner and folding up the sides, find the value of x that maximize the volume. So how can you maximize something? So we have to find the critical points. Why? Because the critical points in the position of critical point, it has the maximum or minimum. Like this one, this is a this one it is a critical point. Yes, in this point it has a maximum, something like this maximum. Okay, same as here. Here it is a critical point. Yes, and top of this point it has a maximum something. So if we find the critical points, then we can find the maximum value. Okay, volume. So this is a box over here. So this is the tall, which is 10, but we cut the corners. The corner is X, as he mentioned. So we have 2 corners in the tall. Yes, 2 corners here, 1 and 2. So 10 is going to be like removed from it 2 corners, 2 X's. So 2 minus 2X. The width, it was 6 inch, but it's removed from it what 2 corners also. So it's going to be what the width 6 minus 2X. Okay. So what he asked about the volume of what? Of rectangle. Okay. So the volume is equal to what? Length multiply width multiply height. Okay. Okay. So we need the length. We have the length. Sorry, here we need the width. We have the width. Do we have the height? Yes. If we flip this rectangle like this one in this shape, this part is going to be the height, which is same as the cut corner, which is X. So height is X. Just find the function of volume, which is this one. Just substitute and multiply this one. Okay, that's it. After that, if you want to find the maximum volume, then you have to find the critical points. Okay, so just differentiate as we did and then solve. So I have 2 numbers, X equal to this number and X equal to this number, but I have to accept 1. So why I did reject this? Because if we substitute this one in the width, because we have the width, yes, which is 6x minus, sorry, 6 minus 2x. If you substitute x here, it's going to make the width negative. How? So this one is rejected because there is nothing like the width is negative. So we have to reject it. But this one makes sense. If we substitute, you are going to have the length, the width, the height, and then just find the volume. Okay, just substitute x here. You substitute x here, you're going to have the volume with a positive number, not like the first x. If you substitute, you're going to have a negative number. This one, same as we did, okay? But it has a small idea, which is this has because this one, it is a rectangle inside a semicircle, okay? Okay, so we know that this is the radius, this is the radius, this is the radius, because it's like from the center, okay? Okay, so we are going to put this in the center and here. Okay, this is the radius. So here is 4, and I know this one is what is also 4, because this one is 4, radius, 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 okay, and so on. So it's going to be what? Is going to be all of this 4, but this one is x and this one is x. We don't know this, so it's x variable. So to know this, to know all this, it's going to be what? 4, what? 4, okay, or this, all this 4, so it is x, or 4 plus x, okay? Okay, so this one, you are going to find it, and sorry, this one is, you are going to find it, which is x, and this one is, we don't know it, okay? So we want to find the formula, which is A equal length multiply what? The width. The length is easy, which is this one, but we don't know it. So we have to use Pythagoras, using what? X equal square root 4 minus x square, sorry, 4, yes, 4 square minus x square. And then you are going to find this one, which is the length. And the width, which is this one, x, and here is also x, so it's going to be 2x. Just substitute it in this formula, and then you're going to find first derivative and then find the x values, and then you are done because you have the two values. So we are going to find at the end like maybe 4 values: x equal square root 2, x equal minus square root 2, minus square root 2, and then x equal to 2 and x equal minus 2, because يعني we know that we cannot have like, because the width is 2x. If you substitute minus 2 here, it will make width minus. If you substitute this here, it will make width minus. So we can reject them. We can reject them, and then we see which one, square root 2 or 2. Which one? Just substitute it in the rest, and you will at the end see that this makes sense, because all of them make like either the length 0 or width minus. So it must make sense. So this is the x. And at the end, he asked us to find the dimensions, which are the length and width. And that's easy, just substitute in the formula, and that's it. So thank you for listening, and that's it.